Hi everyone, this is your math guru. In this video, I'm going to show you how to solve the following question and the equation of a circle. Please don't forget to click on the like and the subscribe button below for more easy to understand math concept. In the diagram, the circle centered at M with coordinates AB is drawn. T and R, having the coordinates of 6 and 0, are the x-intercept of the circle. Its tangent is drawn to the circle at K with coordinates 5, 7. We are to 1. If M is a point on the line y equals to x plus 1, write B in terms of A and also calculate the coordinates of M. The second question says if the coordinates of M are 2, 3, calculate the length of 1, the radius of the circle, 2, TR, and 3, determine the equation of the tangent to the circle at K, writing our answers in the form y equals mx plus c. So for the first part of the question, if M is a point on the line y equals x plus 1, then we should write B in terms of A. Note that the point M is giving us A and B, so therefore writing B in terms of A, what this means is that A is our x values and B is our y values. So substituting that back into the equation, we have y, which is B, equals x, which is A, plus 1. We've been able to write B in terms of A. The second part of the question says calculate the coordinates of M. If you look at the diagram, you can see that, or we've been told from the question that the center of the circle is M, and therefore the distance from the center of any circle to any part of the circle is referred to as the radius. So what that means is the distance MK or MR is equal to the distance MK. They are both radii of the circle. So therefore, if I square both sides and I have mr squared equals to mk squared, using the distance formula, the distance mr will be the change in x values. So we have that as a minus 6 all squared plus the change in y values, that's b minus 0 all squared, that's equal to mr squared using the distance formula, equals, we're going to do the same thing for the distance mk. So mk squared will be a minus 5 all squared plus b, that's the other part, the y values, b minus 7 all squared. Note that we've been able to calculate from the first part of the question that the value of b equals a plus 1. So every occurrence of b replaced with a plus 1. So we have a minus 6 all squared plus b minus 0 is 0, but b is a plus 1, so I replace that with a plus 1 all squared equals a minus 5 all squared plus, we do the same, b is a plus 1, so we have a plus 1 minus 7 all squared. And if I resolve or simplify, I have that as a minus 6 all squared plus a plus 1 all squared equals a minus 5 all squared plus 1 minus 7, that's minus 6, so we have a minus 6 all squared. Simplifying further, I can take out a minus 6 all squared from both sides, so this goes off. I'm left with, on my left hand side, a plus 1 all squared equals a minus 5 all squared. So expanding our bracket, we have a squared plus 2a plus 1 on the left hand side, and on the right hand side we have a squared minus 10a plus 25. Like we did earlier, we can take out a squared from both sides. If I move my a squared to the other side, it becomes negative, so this goes off. I'm left with, moving my minus 10 to the left hand side, I have 2a plus 10a equals 25. I'm going to move my 1 to the right hand side, it becomes negative, so I have 12a equals 24, and dividing both sides by 12, I have a equals to 2. And once I can find the value of a, I can find the value of b. We have b equals a plus 1, which is equal to, a is 2 plus 1, so therefore b equals to 3. So therefore the coordinate of m will be the a values, that's 2, and the b value, that's 3. So we've been able to prove that m is 2, 3. Let's look at the next question. Now that we've been able to find the coordinates of m, the next question says calculate the radius of the circle. Note that the radius of the circle is the distance from the center of the circle to any part of the circle. So I'm going to use point K. I could as well use point R. So what that means is that this m is 2, 3. So distance of mk, which is also the radius, equals square root of, using the distance formula, we have change in x all squared plus change in y all squared. Slotting in our parameters, we have 2 minus 5 all squared plus 3 minus 7 all squared. That's equal to square root of negative 3 all squared plus negative 4 all squared. That will be 9 plus 16. 9 plus 16 is 25, so that will be square root of 25. So therefore the radius of the circle is equal to 5 units. The next question says find the distance TR. Note that at point T is an intercept on x-axis, so the value of y is 0. So point T will be, we have our x values and y is 0. And then we have the center, that's 2, 3. We have m to be 2, 3. Note that we've been able to calculate the radius of the circle to be 5 units, so that means the distance from C to M is also 5 units. So therefore, using the equation of the circle formula, we have r squared equals, which is r squared is the distance, so I'm going to change that to 5 squared. So I have the radius squared equals 2 minus 0, that will be 2 minus x all squared, plus then I have 3 minus y, that's 0, that's the second point, all squared. We have the formula used, I'm going to write that by the side, is the radius squared equals x minus the center all squared plus y minus the coordinates of the y values of the center all squared. So therefore, simplifying further, we have that is 25 equals, we have 2 minus x all squared will give us 4 minus 4x plus x squared. 3 minus 0, that's 3. 3 squared is 9. So we have plus 9. And making that a quadratic equation, I'm going to move all the terms to one side. So I have x squared minus 4x minus 12. So moving 25 to the right hand side will make it negative 25. And if I factorize what I have on my right, I have x minus 6, x plus 2. So therefore, x minus 6 equals to 0, x equals to 6, or x plus 2 equals to 0, x equals negative 2. Note that you can see that the t lies on the negative side of our x-axis, so the coordinate of t will be negative 2 and 0. So therefore, finding the distance tr will be the distance t to o plus o to r. So we have that as 2 units plus 6 units, and that's equal to 8 units. Let's look at the last part of the question. The last part of the question says, determine the equation of the tangent to the circle at K. Write your answer in the form y equals mx plus c. I'm going to start by finding the gradient of the line that has point K on it. Note that is said to be the tangent to the circle, so it's going to form 90 degrees from the center of the circle. So what that means is the gradient of the line MK multiplied by the gradient of the line that has point K will give us negative 1. If two lines are perpendicular, the multiplication of their gradients will give us negative 1. So gradient of line MK, that's change in y over change in x, will give us 7 minus 3. Change in y over change in x, that's 5 minus 2, multiplying the gradient of the line MK equals to negative 1. We have 4 over 3 times MK equals to negative 1. So therefore, the gradient of the line that has K as a point will be equal to negative 3 over 4. If I have that as negative 3 over 4, therefore our equation y equals mx plus c. M now is the gradient, that's negative 3 over 4 x plus c. To find c, note that K is the point on that line, so we're going to substitute for y and x. So y will be 7 and x will be 5. So we have that as multiplying 5 plus c. We have 7 equals negative 3 times 5, that's 15 over 4, plus c. Therefore, c equals 7 plus 15 over 4, which is 43 over 4. Therefore, the equation of the line that has K as a point on it, that's the tangent to the circle at K, will be y equals the gradient x plus c, 43 over 4. Thanks for watching. Bye.